My talk today will be mostly based on the last chapter in this book. So for those who have already read it, you will see the familiar examples, and for the rest, you will know where to find the details if you need them. So today we're going to discuss domain-specific languages, and actually I will use the examples that were mentioned in the previous talk about Kotlin XHTML. I don't know what you were told about it. I didn't understand anything. But there were some examples that will also that we will look in terms of how they work and how they are built. So let's start. At first, what are these DSLs? What are domain-specific languages? And in general, we can divide languages into general-purpose languages and domain-specific languages. And we say that general-purpose languages we can use for everything, and domain-specific languages are just specific for exact use case, for the exact task, for kind of your domain. And an example of such a language would be Gradle. Just a second. So when we look at a Gradle build script, is just an example of something specific to a domain. So here we just create a build script. And you know that before that, Gradle, you can use the classical Gradle, and in this case, it uses Groovy under the hood. And new version of Gradle is written in Kotlin, so you can also write now build scripts in Kotlin. And but it's the same, like the same DSL, just conceptually, but just written in two different languages, two different host languages. And here we can notice the difference. There are also these terms, external DSLs and internal DSLs. And external DSL is something that we create from scratch. So say you have a specific task for your, where you would like to use some probably configuration on your own language or some something specific for your application, and you may choose to create a new language from scratch. But in this case, you have to write parser. You have to actually do a lot of work to support that. And the biggest problem I would expect will start when you want some ID support for your language, some smart tools, and they won't work just for your own custom language. But in general, that's what is external DSL when you create a language from scratch. In comparison, internal DSL uses some host language. So when we're talking about Gradle, twice it's an internal DSL that first uses Groovy as a host language, and now it can also use Kotlin as a host language. So that's like the major difference. And when we're talking about DSLs in Kotlin, writing DSLs in Kotlin, that's definitely about writing internal DSLs in Kotlin that use Kotlin as this host language. And we say that Kotlin is somehow very good for creating such DSLs. Why? And my goal for today is to answer this why question, why it is so good for creating DSLs, and why it's important that we can create DSLs in Kotlin. But first, let me briefly highlight the difference, or probably to say that it's not very easy to make the strict line between just good APIs specific for your library and DSLs. So whenever you create a library specific for your task, and for instance other people use it, it's kind of something domain specific for this task. So it may have a good API that many people will praise afterwards, and many people will use this library and they will say that, wow, it's so nice to use it. And in this case we can say yes, it has this good API, or it might be not that good, but it depends. And it's really a hard line between distinguishing these just libraries with rich APIs and domain-specific languages. So sometimes we may say that in the domain-specific languages we may find some structure of the language, but still it's not there is no easy answer to where is this difference, and probably that's not that important, because Kotlin is good for creating good APIs for libraries and for creating DSLs. So that's something that you can use. That's all that we can use in Kotlin. At first, I expect that all of you are already using Kotlin. Yes, that's amazing. So I will just briefly highlight some Kotlin features that are in general good for creating, that help to create good APIs, and also are helpful for creating DSLs. And afterward, we'll make a diversion into some very specific topic. So some just a brief highlighting of some of the Kotlin features that are often useful when we're talking about improving API, about improving how the language looks like when we read it, how we use the library, how the usage of some functions look like, and whether it's very convenient to read them. So, for instance, in Kotlin we have this feature of infix functions, and that means that you can define your function as infix, and then you may use it in a so-called infix form. So this is when a regular form of using the function, when you use dot, function name, parentheses, and you can replace it as infix form, and in some cases it's much more readable. And that's the functionality that you can use for your libraries, again, in terms of having the goal to improve the resulting API of your library. Another example known by all Kotlin developers is extension functions. It's also something that helps us to create good APIs and also is useful when we're talking about DSLs. So here, instead of using this util function, we just define string, and we may use these call extension functions on the receiver directly, and that also improves how our code may look like. Then in Kotlin we have operator overloading. In this case, here we have like two custom point classes. Here I define data class point, and I allow them to be summed up using their concise syntax, not using the full syntax with plus, but using overloaded operator with just plus sign. So here, instead of using this point like plus, I can replace it automatically with plus. So that's another thing that may improve how your library looks like, how convenient it is to use it, and how enjoyable, for instance, it is to use it by your users. Another important feature that I won't cover today, but it's still another something that brings a lot to the power of creating DSLs and creating good APIs in Kotlin, is these delegated properties. So here is the lazy example, but the main thing here that instead of this lazy block here, we can delegate to different functionality, to different approaches, and it also it's very useful for creating complicated systems and good APIs. So that was kind of brief highlighting of the features. You may find more if you're interested in exact details of which one. And what I'm going to focus on today is the most classical thing that is understood when we are talking about Kotlin DSLs, and that is Kotlin Builders. And the feature that allows us to write Kotlin Builders is Lambda Wizard receiver. So for the rest of our time, I will discuss these Kotlin Builders. So who already is familiar? The same people who wrote the book, no, not the same, but there are some intersection. So, okay, so some are not, and I will explain who are they, why, like what do they represent, and the most interesting, I will try to explain why it's so great that we can have such thinking language, what benefits we can get using these Kotlin builders. So let's start with an example. And a good way to think about, like one of the ways to think about Kotlin builders would be that they can replace some, like actually any XML configuration. So whenever you use kind of custom XML, I googled some trivial XML for this talk, just somewhere. And whenever you have something like XML and you want to put your configuration in some XML file, you can instead express that in the Kotlin code. So I think saw this already in the previous talk in the Kotlin HTML. So now let's unwrap it and see how exactly it works. So this is my XML, and when I convert it, I have something like this, and this is Kotlin code. I will just a second. I will split the screen so that you can could compare it, and you can see that they are quite similar. So Kotlin allows us to create to build structures that are very similar to the ones that we have in regular XML. And at first, let's discuss how they are built, and then discuss why it's so important. I think I forgot something. Before we return to this example, I wanted to introduce you also the functionality of Lambda Wizard receiver. Who is already familiar with this concept of Lambda Wizard receiver? Some of you. So okay, but the rest of you are familiar with the concepts of Lambda. Okay, so Lambda is an anonymous function that can be passed as an argument or stored in a variable, and Lambda Wizard receiver is a very specific case of Lambda. So here we have the typical code in Kotlin that just builds a string. So here we call build string and pass a lambda as an argument, and inside this lambda we can append strings to the resulting to the result. So if we run this code, we see that we get what we expected. So we have alphabet and we have the whole alphabet. And let's try to declare such build string functions. So this one is used from the standard library, but let's now try to define a similar function. And at first, I will start with defining a function that takes regular lambda as a parameter. So what I do, I create a build string function, and I want to take lambda that allows me to do something with string builder. And if we, for instance, write code in Java, if we're not familiar with this, we don't have these lambdas with the receiver, what we do is we expect some builder action of the type of the regular lambda. So here I define a function that expects lambda as an argument. And in this case, my lambda takes string builder as a parameter. So string builder, because yes. So here I define a function that takes that takes lambda that takes string builder, and then I might when I use this, I specify my argument of this function as string builder, and afterwards I can append everything to this string builder. Note that probably not everyone is familiar with the Kotlin syntactic Kotlin syntax, so the full syntax to pass lambda as an argument would be to say function name parentheses, and then inside this parenthesis goes lambda. So here we just create a function that takes lambda as an argument, and inside this lambda we append we can append something to string builder. In Kotlin we have the convention that if lambda is the last argument, we can move it out of the parentheses. So we have even indentation for that, and you can just omit the parentheses. So alternative way would be to use empty parentheses, but if they're empty, you can just omit them and pass lambda after the function name. So that's the similar convention works in Groovy, and it turns out that just this syntactic small thing really is very helpful when we for defining these Kotlin builders as well. As we'll see, it works really great when we are using this, creating these string builders. So in this case, at first, let's return to our function. Now it just does nothing, but what we want to do inside this build string, we want to build a string. And what we do inside this function, we create an empty string builder. Then, I think we don't need it here. Then we call our builder action on this string builder. So when we call builder action, when we like here, we call the lambda. So we, in this case, we will append all the strings to this string builder in this line. And in the end, we need to return our string. So we say return string builder to string. And let's specify our string. Let's check that this function works, and it should work like before, like the function from the standard library. Yes, it works. So again, we defined a regular function that takes a regular lambda having the first parameter, and using this lambda inside this build string function. But what we can do, what we can improve, what we can change in Kotlin is we can say, okay, look, I use this string builder here explicitly all the time, and I have to repeat its name, and I have this specific argument. And what lambdas with receivers allow us to do, they allow us to say, okay, this specific argument should be accessed as this reference. So now we say that our lambda has a receiver instead of this argument, and we access this receiver by this reference. So we just take and replace all string builder invocation to this. In this case, we have to also replace the function declaration so that it expects a lambda with receiver. But there's some details. The important thing is here that we replaced one of the arguments with this. That's it. That's the whole story. So lambda with receiver is just lambda with one very special argument, this. And inside this lambda, we can omit this reference. So there is this convention always works in Kotlin. It works for extension functions. It works even in Java when you just use this inside the class. You always can omit this reference and just access members without specification. We can do the same here. We can omit this. And now this code looks like the first slide when I show you that we have here lambda with receiver, and we access its members by specification. And it turns out that these lambdas with receivers are really crucial for building DSLs, for these Kotlin builders. One more thing that we can change here, like who are here Kotlin developers, what can be changed here, like how we can this classical apply with run functions. Yeah, we can rewrite these 3 lines into 1 line. So in Kotlin we have this nice apply function that will replace these 2 lines. Not these 2 lines, but we can say apply builder action, and that will do these two actions at once. At first it creates a new string builder, and then it applies what is specified as an argument to the string builder and returns string builder as the result. So now we can also inline this variable inline, and now we have this nice short Kotlin syntax that is at first that may look strange for those people who not used to it, but when you start using Kotlin, you say like, hey, why you don't use apply here? Okay, so that was our first example, and then the next thing I want to show is I want to edit settings, and we have parents, and yes, I want to show parameter names hints, and if I apply this setting, apply, yeah, now you see that it shows us the hint what is the type of implicit receiver for this lambda. And interestingly, remember, yeah, I've shown you Gradle build script written in Kotlin. And if we return now to this Gradle build string written in Kotlin, we find out that we have here lots of implicit receivers, lots of lambdas with implicit receivers. And that was what was so, like, that kind of explains why they did all this transition from Groovy to Kotlin, because in Kotlin you have static typing, and when you, for instance, here call Kotlin, you cannot call something else here. So this Kotlin is actually function resolved statically on the implicit receiver. It seems that it wants me to rebuild, but I. Okay, we'll hope everything will be fine. So here, this function in Kotlin Gradle DSL is just the member that we are calling on this implicit receiver. Same with just center, etc. And we can't call something wrong here. It shouldn't. Yes, now it doesn't compile, and that's exactly what they wanted from Kotlin. They wanted this static typing and ID support for the ability to see what methods can be called here, what cannot, what you can do, what methods are available, etc., etc. And all this lambdas with receivers allow this functionality. So this is crucial feature for this case. So let's now return to our any questions here? Let's now return then to my example with XML, and have some papers, and let's try to implement it. So let's see how we actually define such DSL, such constructs that correspond to XMLs. So we saw that somehow Lambda with receiver is the central figure of this story. But now let's see how exactly that works. And I have a small starting example for me. So now I have only, here as the result, that's a very simple example for illustration. So as a result, I want an instance of breakfast menu here. So I have breakfast menu and several items, as you've seen. And as a result, I want an instance of breakfast menu with all the items stored inside as in a list, and each breakfast menu item is just a regular class. So let me uncomment it, and we'll see that it doesn't compile because we haven't yet implemented anything. And what is the core idea of creating such builders, Kotlin builders, is that this function expects Lambda with receiver, and item is a member on this implicit receiver. So now let's create this implicit receiver class. So it would be a special class breakfast menu builder, which will just build our breakfast menu. And we can now define this function breakfast menu that should expect implicit receiver of this newly created class. So now let's move on so that we didn't see that our code doesn't compile. So here we have this breakfast menu function, and it expects an instance of it expects Lambda with receiver with implicit receiver of this newly created type. So now if we add function item here, everything should compile. Yes, it compiles. So see, we defined a breakfast menu function that takes Lambda with receiver as an argument. And this Lambda with receiver, this newly created class for Lambda with receiver, inside has this item, and each item should add new item to the list. In this case, let's first implement our breakfast menu builder. It will just contain a mutable list of items, breakfast menu item. Yes, and it will have function build that creates a breakfast menu, the result that we are interested in, and it just uses these items, this breakfast menu, and uses these items that we somehow create. Each item function that we call should what should it do? It should add new item to this list. So here we have, you see that my function item takes 3 arguments. So in Kotlin, if someone is not familiar, we have this syntax. You can specify first argument name equals sign and argument value. So this is, we just call the function specifying 3 arguments with their names. So here we just need the function that takes the same 3 arguments. I think I can copy paste them from here. Where is it? Item? Yes. So I just copy paste the arguments. So when I call item, I pass all these arguments. My item function is called, and what should be done inside? Yes, I just need to add my breakfast menu, newly create this breakfast menu item, and add it to the list of items. That's it. So here there is my result, and I can, I think, print. Breakfast menu. No, we created this breakfast menu builder, but for now our breakfast menu function does nothing because we haven't yet implemented. So now, what do you think should be done here? So what should I do? I should create breakfast menu builder. Breakfast menu builder. I hope I haven't imported something. Yes. Then I should call init function on it, and then I should return the result. The result is built, and here our breakfast menu should return our class, our breakfast menu class. Kotlin experts, do you know how to simplify this code? You know, yes, apply function does the job, yes. So we can here say apply init, then we can inline this function, and here there is this pattern that is always used whenever you use this. You create these Kotlin builders, you build and you create a new object, apply this lambda, and return some result. So now we can call this main function and make sure that everything works as I expect. Yes, and it returned us it returned us breakfast menu with the list of items that we passed. So here in my example, I had only one item to make it short, but in another example, I have a lot of items. So that was a simple example for you to understand how it works. Then, still I hope I have time, and we can move to a little bit more complicated example. The one that everyone is familiar with is HTML. And now we are closer to that Kotlin HTML that was mentioned in the previous section. But at first, I want to show you how, like, a little bit how it is built. So how we create. Let's start with so this is not Kotlin HTML yet. It's my small example in just 3 tags: table, parent, just for illustration of the whole idea of how we built this thing. And Kotlin HTML library contains the same logic, but for lots of the tags, probably most of them, but not sure. So here we have something that looks like XML. I've also have a special XML, and I can split vertically, and I can use my open my XML example here, so that you can one more time ensure that yes, they look straightforward. Like there is this straightforward correspondence between my XML and my code using Kotlin Builders. However, there is this interesting difference. You see, in XML, I can't use Kotlin code. There is just XML. And for instance, when you have HTML, you have to invent some, like, lots of template languages of how to introduce some language like constructs, control structures, like, I know when we want to repeat something, when we want to use condition. There are a lot of technologies that cover exactly this case. And here we have it for free, because it's the language. It's just the Kotlin language. And we can easily mix these tags, these builders, with Kotlin code. Like in this example, when we repeat this tag twice, it is generated twice. So it is specifically very, very simple, just tags to illustration. But in real life, of course, there are lots of data and a lot more complexity. So now we know what we want. We know we want to create these tags that allow us to create these builders. And because I switched on this hint that highlights the type, you already know what should be the types of these implicit receivers inside these lambdas. So you can see that here we have lambda with implicit receiver of the type. So we named it this way, so it corresponds to the tag, but it is written in capital letters. Here also lambda with implicit. No, this one. Lambda with implicit receiver. You can see the tag name, and here as well. So you can see all these different implicit receivers. So now let's move on. No, wrong button. And try to implement it. So at first, again, I have some example that won't compile. Probably I leave it as is, and I will try to implement this simple logic to illustrate you, to demonstrate how to create such builders. So I have my something that helps me. So here, like before in breakfast menu example, I have only one thing that I wanted to build. Here I want to build all the tags, and because of that, I will need to have a superclass that all the tags will extend. So at first, I will define open means it's not final in Kotlin, a class tag that takes name as an argument. And second, yes. And what should I put inside? So as before, my tag would just store its children. So before we have this breakfast menu and it stored its child items. So here we actually have this similar idea. Each tag can just store its direct children for simplification. And this will be tree structure, and each tag will correspondingly store its children. So here we can define val for children, and it will be mutable list of tag of the class tag. And also, because it is HTML and we want HTML representation, I will override to string, select none, and in this to string I will return like regular XML representation for it. So I'll return first. We'll wrap it in text, and in between I will just join all the children. So this is my implementation. So by default, join to string joins with comma, and I will join to just nothing, and that will give me the following representation for this. We had it in the slides. This table true without today. So that's without any new line characters, but still enough for our demonstration purposes. And so, okay, we have now the tag that stores its children. Now we need the classes, the exact classes that extend this tag. Exact classes for my 3 tags. I have 3 tags. I have tag table. I have tag tour, and I have tag today, and they all extend my tag superclass with specifying their names. So I just write that, and the same here. Yes. So that's the first part, and now I can already define at least this first table function, because I now have the table tag. So again, the same pattern. We define the function that takes builder with receiver as an argument. So here I should define the variable that specifies this lambda with receiver. So I say init. Here I know that my receiver should be of type table, the one defined here. So I say table, and again my lambda should just add something to this table and return it. Here I can implement it. No table. Are you tried? Return table. Yes. Here, so that's my result. We implemented table. However, we still now we have that we have the first this here appeared. You see, now our code is not compiled yet because we need to add the member functions to the corresponding tags. So we have the tag class table, and we just add the function that specifies the implicit receiver of the receiver that it expects here. So this function expects that should be this ter. We know we already saw it when the example was working. So now I know which class should I specify here, and which type of implicit lambda should I specify here, and it's this one, and the same one for this function, but here it should be this one, right? So I haven't changed the name. Yes. So now you see that my builders now compile, and I see all these right implicit receivers here. The only thing is left is we need to somehow add these tags to children here, because now we just create them and don't use them. And first I will make this val protected so that I could explicitly add it to the children. So what I do here, okay, I will just say apply right away. Also, and I can use another nice Kotlin function also. No, not also in it, but also I want to add it to the list of parent children. I think I need to use actually this table for this. This a little bit probably complicated syntax. So here I use the children of this table and add myself this tag that I've just created to this. The same I can the same logic I can do for another tag. Here I create 2D, I apply, and I add children. I add myself to a parent, to children of parents. But the thing is that I can, you see there is some duplication of the code, and actually I can remove it, and I can just extract this to the outer class so that my children property was private, but I would add a protected function because it can be used on any tag. It will be a generic function, and it will just contain the logic that I had to repeat in this text. So it will say child init. Actually, I don't need to return my child anymore because we just added to the list to our parents list of children. And now instead of using this apply also, I just say do we need create tag and this do we need create tag and calling this lambda. So that last story of doing it was just to extract this duplication. So it's just I have this repetition and I extracted it to the super function. Like if you need more details, like what's generic, etc., it's might be confusing, but it's not the point here. You know where to find all this information and the explanation. I have something because I forgot to remove this this thing. So let's try to run it. I suppose it should work. Yes, but we don't print anything. So I need some main probably. Where is it? It's somewhere below. Yes, it was commented. So here, if I print, I expect. No. Yes. So we have now implemented these HTML builders. Simple one. Questions? Okay, that's not all. Sorry, Hadi, I'm not there yet. So we have one more example. And the next example will actually explain why it's so great that we have these builders. And the answer is because we have this power of abstraction. So we can reuse some components that we want because we now have the full power of the general purpose language actually. So we are not constrained with just XML, with inventing some template engines to allow some control structures. We can do everything. And to illustrate that, I will use some example. Again, HTML. But in general case, this builders works for any XML that you can invent. So whenever you have in your application some configuration setting that you think, probably I can put it in XML, then you can think twice, and probably you can put it in Kotlin DSL. In this case, you'll have the similar structure and the power of the language, and you can express everything inside Kotlin directly. And you see that this transformation is quite straightforward. So it's not a rocket science to define all these builders. So that's kind of automatic thing that you do. So now the next example, and this example is some HTML Bootstrap library that specifies, like in this case, we want to create drop-down list, and it tells us which exact classes we should use to define our drop-down list. So it's kind of the code that you just duplicate. So you copy-paste it from the documentation, for instance. Then you replace here like all the names. You have here, you can have several similar elements, and that's how it works. And as I've told you, and as they told you in the probably in the previous talk, we have in Kotlin, we have Kotlin HTML library that now is added to my project as a dependency, and I can express the same code. Okay, I will do the same thing again. I will split vertically, so you can make sure that it's again very similar code. So when we use our Kotlin XHTML library, so here we have div here, and after div we have very similar like direct correspondence between tags and the Kotlin functions that we call. And these Kotlin functions that, as you know, will take lambdas with receivers. Here we see, and you see that this naming I just reused from this Kotlin XHTML library. They name all these tags as in uppercase. So here we see the direct correspondence between these two examples. And I imagine I wrote this code, and I want this drop-down repeated somewhere. And I think like, what can I improve here? And again, I need my paper. And what I can, like, I see, there's some code duplication. We have similar, this should be just menu item, and we have this menu item repeated twice, and with a lot of ceremony. The same ceremony. We have the same word, we have the same reference. And the only thing that is meaningful here is this link. All three occurrence. It's temporary. And this name. No, that's not what I wanted. Yes. And what I can do is I can extract method. Call it, for instance, item. Then idea nicely suggests me to replace two more occurrences. Then I can inline. So this trick was so that inline method understood that I have a couple of parameters. So you now see that we replaced like kind of long ceremony with three clear functions, with three clear function calls. So now we can avoid this ceremony and improve the way how our code sample looks. I can continue. For instance, here I have so in this case this one is just in my case divider. So I can just extract their divider, and whenever I want divider to be added to my drop-down list, I can just call this function. The next one is some header, and in this case I want this text as a parameter. I think, right, yes. And I can again extract it and call it drop-down header, for instance. And I will align my variable. So now my first example starting to look much more readable. Then I will do the same trick with other functions. So here, to let IntelliJ understand that this is my parameter, I will briefly extract to a block of code. Then I will say say extract method, call it drop down menu, and inline block of code work. That's I need to move lambda out of parentheses. So you see now it looks much different. And this the last trick, the same trick with the pattern function. Again, I will extract it add it to a function. It will be called drop down button. Then I will inline, and also I don't want to so like all my span declarations can be defined in the function explicitly. So now here I can say first call my block and then apply these class files. So that's one more way to simplify of my refactorings. And my last refactorings I can again replace. So here probably I can. I'm not sure that it will work. So I will just define my last function drop down menu. And that will be the function that calls all the rest. Second. So I need here the same drop down menu and block. So now I defined one more function, and it should be just drop down. I think I've missed something. Sorry. That's because it's not that trivial. So here I want. So what I'm going to do? I want to get rid of this last div class. For this case, I need to know what my create HTML. So like now there is some specific of Kotlin HTML. It returns me tag consumer, and I can define extension function on tag. Okay, let me just I think copy paste it from my example. Yes, it's here. To simplify it, so that's how like the point of the entry point looks like. And now I can replace this div, this main div to this drop down function as well. So now my drop down. So yes, now we have the final example, the one that I was intended to show you, to demonstrate. And if we write this code, yes, we have main, and Kotlin HTML inside builds all the tags in the right way. So if we call it, you'll see that it gives us the initial code, the initial tags, with all these right tags, with all the classes, with all the verbosity. But when we use this code, we see this very, very concise syntax. And again, I will show you, like, let's split the screen. No, let's do this. This split vertically. And here I want to show you, like, our initial example, and you can compare it with what we have in the end. So here we have all the classes, and as the result, when we can express it in the Kotlin code, we can simplify it and improve the readability in a in very big respect. So this example is much more readable. So okay, I've used some magic when I extracted all these functions. So if you try to follow, you'll understand which is extension to. But the idea is that basically often you can really do it kind of automatically. Even IntelliJ can help you. You use all these extract methods. It will automatically generate you all the right types. So that's something you can also do whenever you use something like this, like structures, and having them defined in Kotlin will allow you to do something to do such things, to extract repetitive code into functions and to reuse them. So basically, Kotlin Builders to solve our the regular pain of developers, how to try to avoid duplication, how to avoid the fact that we need to duplicate some code, and how to allow more expressiveness to be able to reuse lots of pieces of the code in your application. So that was the end of the story for today. If you're interested, this examples, I just used the samples from a book, so that's how it looks. They told us it's a Russian woman. I don't really believe them, but okay, probably it's a Russian woman. And in the very last chapter, we have exactly what I've just shown you covered in detail. And we have the same drop-down example demonstrated. So if you're interested, you can check it out just to see how it works. And also, I have this example available at the GitHub, so you can also, if you're interested, you can see all the declarations automatically. So thank you very much for your attention.